circle. So let's go ahead and get started. In this diagram, we're going to do is we're going to show two chords here, which effectively are going to be the result of creating two secants. So we have our center that's here, and these are going to be clearly not, excuse me, these are not going to be diameters. So these are chords that are not through the center. Oops, let's not make it there. Let's make our chord right here. Chord names, we have A, B, C, and D. And then I've drawn that center just so that we can see that our point is not on the center there. And what we have here is a few segments. So these intersect at point E. Our segments are lengths 6, 3, X, and 4. Now, when we have this, we have two chords that are intersecting. It's going to actually be a great relationship that I'm going to exemplify for you. It's rather straightforward. It's going to be the product of the intersections of those two chords. In other words, AE and EC multiplied together is going to be the same as DE times EB. All right, so if we have those measurements, we can actually just go ahead and input values here. And this is going to be the same for any time that we have segments that are chords that are going to create these subsegments, right? So we have these two intersecting chords created, right, of course, from the secant. So we have 6 as AE, EC is X, DE is 3, and EB is 4. So of course we have 6x is equal to 12, and we can solve that x is equal to 2. So EC would in turn be equal to 2. All right. Next. Start to get a couple other segments can happen here. Excuse me. For example, when we have secant, right? So we already talked about this in our previous lesson, that if we have, let's go ahead and get rid of that, secant, and we talked about the angle relationships from secant, but here we're going to actually discuss the segment relationships, okay? So we have ABC and DE additionally. AB is 10, BC is 24, AD is 8, and DE is X. So the way that we construct this is as follows. It's going to be the outside segment times the whole segment, where we'll have the ratio between the two, right? In secant. So AB times the entire segment, which is AC, right? An entire secant. And then we have AD, the outside portion, times the entire thing, which is AE. All right? So we start to solve here. We substitute AB, which is 10, times AC, which is 34, 10 plus 24. We have AD, which is 8, and then we have AE, which is going to be AD plus DE, or 8 plus X. And we start to solve. We're going to get 340. 34 times 10 is going to be equal to, we're going to distribute. 8 times 8 is 64. 8 times X is plus 8x. Subtract 64 from both sides, so we solve for x. So 340 minus that is going to be 276, equal to 8x, divided by 8, both sides. And x is going to be equal to 34.5. Now, this isn't just limited to secant. We could also do the scenario where we have something called secant tangent, okay? And it would look like this. secant tangent. We have x plus 4, we have x, and we have x plus 2. And we're going to solve for x. All right, the way this is done, it's going to be, when we have secant tangent, the outside segment, right? So just as a little sidebar here, giving you like what the formula actually looks like. We have a secant tangent, right? So we have our secant here and our tangent here, and we call this A, B, C, D. What we have is it's the outside segment, AC, times the whole segment, AD. And what's great is that it's going to be the outside segment, AB, times the whole segment, which is one and the same thing, right? The outside segment of the tangent is the same thing as the entire line. So in other words, it's AC times AD, which is equal to AB times AB, which is just AB squared, okay? So let's go ahead and do that. We have the outside, right, which is going to be X, and that's going to be times. We take the whole segment here, right, which is x plus 2, and that's going to be equal to the outside x plus 4 times itself, so x plus 4 squared, okay? Or in other words, this is x times 2x plus 2 equal to x plus 4 squared, which is a binomial square. So we distribute here. This is going to be 2x squared plus 2x. The binomial squared, when we FOIL, x squared plus 8x plus 16. And then we start to solve, right? So I'm going to move all of this stuff over here. So I have a quadratic that I'm going to wind up solving. Subtract x squared from both sides. Okay? Subtract 8x from both sides. And subtract 16 from both sides. 2x squared minus x squared is x squared minus 6x minus 16. That's all equal to 0. These are all going to be canceled. Then we're going to factor x and x. Two factors of negative 16. They're going to have a sum of negative 6, so it's going to be a negative 8 and a positive 2, going back to that skill from Algebra 1. And then we're going to solve, and x is going to be equal to 8, and x is going to be equal to negative 2. Except for that, you're going to go back here, and I want you to consider this. Let's look at this. Could I go back in and make x equal to negative 2? Does that ever make sense to have that negative distance there? And it won't. So this right here is extraneous. So our only answer here is that x is equal to 8. All right. Bunch of these problems here. You may need to use the quadratic formula to solve one of these. Okay, you never know. You're going to have radicals come up that you haven't seen in a while. So making sure that we're doing that. I'm going to do one more problem here, which is we're going to find the radius of the following circle. It's going to be this. Is there a circle? Let's make it a better circle there. My center, there's R, right, my radius. I have 1 and 3 for my tangent right here. And this is V, U, T, this is W. Let's solve for the radius, okay? So setting this up, this is going to be UT squared, right, times itself is equal to UV, the outside, times the entire segment, which is WU. So UT squared is going to be 3 squared. UV is equal to 1 times WU, which is going to be 1 plus R plus R, okay? Or 9 is going to be equal to 1 plus 2R. Subtract my 1 from each side. So 8 is going to be equal to 2R. So my radius is going to be equal to 4. And that's it. Saintsman, that's all I got for you for today. So your assignment is posted on Canvas. Go ahead and get started. If you have any questions, contact me via email. Good luck.